Good afternoon, everyone. This is Muradal Quraishi. Today, I will present my research work on deep learning and UAV based solution to real time pavement condition assessment. The overview of the presentation is divided into multiple sections. We will discuss in the first section motivations, then objectives, overview of the proposed method, data acquisition, model comparison, configuration of a Raspberry Pi camera module, testing on real-time video, and conclusions. Motivations. According to the 2017 ASC report card, bridges rating as C+, and roads rating as D, which means poor at risk condition. 20%, 21%, or approximately 1 out of 5 of the US highways had poor pavement condition in 2015. Traditional vision-based inspection is time-consuming and costly. Aging infrastructure calls for more frequent inspection, so we need frequent inspection for better safeguard life and economy. Objectives of this study is to find out an appropriate neural network model which can detect different types of pavement cracks, deploy the model in a microchip to make it feasible to carry with a drone, make the pavement condition assessment in real time more efficient and cost effective. Overview of the proposed method. We proposed a real time and low cost solution to autonomous condition assessment of pavement using deep learning, unmanned aerial vehicle, and Raspberry Pi microchip computer. We conducted experiments to compare the performance of various combinations of meta architectures such as faster R-CNN, R-FCN, SSD, YOLO with feature extractors such as Inception version 2, NasNet, ResNet 101, and MobileNet version 1 for pavement distress classification. A low-cost Raspberry Pi Smart defect detector was configured using the most efficient model. The defect detector was attached with an UAV for real-time and remote pavement condition assessment. As you can see in the figure, in the first step we collect image, then label the image, then train the model, then evaluate the model using the test data, then based on the most accurate and speed, and configure the Raspberry Pi with the trained model, then uh, test the Raspberry Pi with real-time video, and attach the Raspberry Pi with a UAV. We collect data using a DJI Panther 4 Pro drone, and it has a 20 megapixel camera. We collect around 2088 images. This is the sprite image of 2088 image, and we label the images based on the STM D64338 standard. 11 common types of flexible pavement cracks and 8 types of rigid pavement cracks were annotated to train the models. The dataset was split maintaining an 80-20 ratio. That means 80 for training, 20 for test. We compare the total loss for a total of 6 object detection network models with respect to the number of epochs and the total loss. In the x-axis, uh, there is number of global steps, and in the y-axis there is total loss. So loss in neural network defined as the difference between the predicted and the expected output. The epoch in the horizontal axis represent an iteration of overall all the training data, both forward and backward. At each iteration, the neural network will compute and upgrade weight. The more the iteration steps, the less the loss will be. It is observed that It is observed that the faster R-CNN with Inception version 2 model has the smallest total loss, while the SSD with Inception has the greatest loss. The loss of R-FCN with ResNet 1.1 reaches a minimum after less than 20,000 epochs. This is faster R-CNN, and this is the SSD with Inception version 2. The accuracy for the YOLO is very low and it is not shown in the figure. The result in the table indicates that faster R-CNN Inception v2 has the 98% mean average precision, and SSD MobileNet version 1 it has the greatest real-time speed 31.8 frame per second. As you can see in the figure, uh, in the left, this is faster R-CNN and Inception, and in the right, this is faster R-CNN and NAS. From the figure, you can see the model can detect uh, different types of cracks, such as transverse crack, longitudinal crack, block crack, weather raveling crack, and miscellaneous crack. If the model failed to detect any types of crack, it classifies the crack as a miscellaneous crack. And if P means flexible pavement and RP means rigid pavement. For example, this crack is transverse crack and the model is 99% confident that this one is a transverse crack. In this figure, this one is the faster R-FCN and ResNet 1.1 and this one is R-FCN and ResNet 1.1. As you can see, the model confidence is different. This one is 98%, this one is 88%. The left one, this is the SSD MobileNet, middle one is the SSD Inception, and right one the YOLO. As you can see, the YOLO has the least accuracy. That means confidence level. Then we configure a Raspberry Pi defect detector. This is the Raspberry Pi 3B plus, and this one is the neural compute stick. So we put the model in the neural compute stick, and this one is communicate with the Raspberry Pi, and the Raspberry Pi gather the data using the Raspberry Pi camera, and it shows its output in the display, and it gets the power from the uh, power bank. This is the flowchart how the Raspberry Pi and the neural stick communicate with each other. So we test all of the model, train model based on the GPU based computer in real time. And we found that SSD MobileNet version 1 shows the uh, shows more speed compared to the faster R-FCN and ResNet 1.1. After the training, we put the Raspberry Pi in the drone. This is the neural network stick, and this is the Raspberry Pi camera. This is the drone camera. And we fly that drone, and we found that Raspberry Pi uh, shows 1.2 frame per second for 1 second for 1 minute real time fly, and it shows 60% accuracy. Conclusions: smart pavement condition assessment reduce the time and effort to prepare a good and timely maintenance plan for highway and local street pavement. In this work, we proposed an efficient method to detect cracks in the pavement using UAV and AI. Among the latest four models, R-FCN and the YOLO are faster than the faster R-CNN. while faster R-CNN gives better accuracy. YOLO has the least accuracy, and SSD MobileNet shows more compatibility for Android and Raspberry Pi. Trained Deep Neural Network Detector consists of SSD meta architecture and MobileNet feature extractor is fed into the Raspberry Pi through a neural compute stick. The Raspberry Pi shows 60% accuracy of detecting pavement cracks in real time. Thanks for listening me.